Lesson 3-7 from yesterday, we were working on making sure we understood how to use the coordinate plane and graphing 2 points, and then we started talking about how we can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. Today we're going to spend a little bit more time, again, finding the distance on the coordinate plane. And we'll be doing this using what we know as the distance formula. So to find our A and our B, and we started to talk about this yesterday a little bit, is we can look at our X values and our Y values to determine how far this is without actually having to count it, because eventually we're going to be just given 2 points, and you may or may not want to graph all of them. You can figure them out mathematically. So let's look at these 2 points here. We have 1, 2, 3, 4, and then up 1, 2, 3. So we have 4, 3, and then this point here is left 1, 2, 3, 4. So we're at -4, and down 1, 2. So -2. And so when I look at x2 and x1, what that refers to is if we call this point number 1, and we call this point number 2, then what we're doing is we're saying that this here is x value 2 and this here is x value 1. So you can get that in any order that you'd like. So actually in this case I'm going to go ahead and flip these around, and I'm going to say that our positive value here is 0.2. Just so that way we're going from left to right. 1 is over here and 0.2 is over here. So we'll say this one is 0.1. So for x2, I'm going to my second value point, so that's going to be a 4. So I'm going to say 4 minus, and I'm going to go to x1, and x1 is here, that's -4. So 4 minus -4, that's an uh-oh. So that actually equals 8. So A equals 8. So if we said that this is A, we're saying that this is a distance of 8. And again, we kind of said this yesterday by looking at these two right here and saying, yep, we have a distance of 8. So they're distance apart from each other. -4 over here, +4 over here, and there's 8 in between. So there's just kind of a mathematical way to do that. So looking at y2, this is our second value, so y is 3, so we're going to say 3 minus y1 is -2, so 3 minus -2. So as you can see, we have an uh-oh. We'll fix that uh-oh, and so we'll say that b equals 5. So this distance here is 5, and I know that I can use Pythagorean theorem to figure out c. So right now we'll say 8 squared plus 5 squared equals c squared. And so then we say 64 plus 25 equals c squared. And then when we add these two, it would be 89 equals c squared. Then, of course, we want to take the square root of both sides. And so we're going to say that c is equal to, and then we'll go to our calculator. We'll find the square root of 89 to be about 9.4 units. So we want to say about 9.4 units. Okay, so according to our calculator, that's what we got. Again, we want to make sure that we do include units with our answer, just because we are talking about a distance. Now, as we get into this, like I mentioned before, we're actually talking about a formula called the distance formula. So again, you can continue to think about the Pythagorean theorem, and each one of these that we do, if you wanted to graph it on a grid, you certainly can do that. Okay, so you can always graph it like this and then count your lines, so that way you can find out what A, B, and C are. We know that this is going to be 1, 2, 3, 4, and this is going to be 1, 2, just by counting. It's really easy here when we have a graph and we can just count it. But the question comes as, what happens when we don't have a graph? Well, you can either graph it or you can use something like the distance formula to help you figure that out. So again, we're talking about x1 and y1. So right now, if we say that this is 0.1, okay, and I always use my furthest left point for 0.1, so that's this one right now. So we say that it's 0, 1, 0, comma 1. And 0.2 is going to be 1, 2 to the right and 1, 2, 3 down. So it'll be 2, negative 3 for 0.2. So now we see here this whole distance formula, it's already set up for us to solve. And if you really think about this, what this really is C equals the square root, okay, of A squared plus B squared. Because if we look back at this other problem, here it says A equals x2 minus x1. And then now if you look at our distance formula, it says x2 minus x1. So really we're saying that this is A and we're squaring it. So we know that to solve for C, we're eventually going to have to take the square root. So hopefully you're noticing that this here is actually the Pythagorean theorem, but just broken down into all of its little parts. And we're already getting set up to solve for distance. So you won't have to do a whole lot of extra work. So we can just say D equals the square root of this whole thing. Okay, so again, 0.2, we're looking at x, so that's just a 2. So we're going to say 2 minus. Now we're going to 0.1 and looking at x, that's a 0. So we say 0 and then we're squaring it. Okay, all we have to do is substitute items into this formula. Okay, so y2, this is 0.2, y is negative 3, minus y1, this is 0.1, y is 1, and we're going to square that. So now we'll just copy everything down again. D equals the square root of this whole thing. 2 minus 0 is 2, so I'm just going to say 2 squared plus negative 3 minus 1. Well, that's negative 4. And remember, we're squaring this whole thing, not just the 4, but negative 4. So now D equals the square root of, we're going to have 4 here, plus this negative 4 times negative 4 is positive 16. So D equals the square root of 20, and now we can actually find the distance to the nearest unit. So we need to find the square root of 20, which is about 4.5 units. So we'll need to go back into here and say it's about 4.5 units. Is our distance between 0.1 and 0.2. So from this point to this point, it's about 4.5 units. Okay, so for our next example, again, continuing the same thing. Okay, 0.1 is going to be right here. 0.2 is going to be right here. So we're going 1, 2, 3, 4, 5 to the left. So that's negative 5. And we're going 1, 2, 3, 4 up. So that's a positive 4. 0.2, we're right on the y-axis. So we're still at 0. And then 1, 2, 3, 4, 5 down. So negative 5 for the y-coordinate. So again, I'm just going to copy this equation. D equals the square root. Now I need to plug things in. So x2 is 0. Minus x1 is negative 5. Make sure you include that negative there because you know we have an uh-oh. We'll fix that in a second. Y2 is negative 5. And we're subtracting y1, which is 4. We're going to square that whole quantity. So make sure that squared symbol is on the outside of the parentheses. All right, so D equals, then we have an uh-oh right here. So we're going to say 5 squared plus, and we're going to get negative 9 squared. And so we're going to say D equals square root of 25 plus 81. And we'll combine that quantity. So the square root of 106. And we'll need to go to our calculators to be able to estimate that. So 106, we'll take the square root, and so we get about 10.3. So D equals about 10.3 units. Again, we are talking about a distance here. Actually, this is called the distance formula, so make sure you're including units. It does not say centimeters or anything, so we can just say units. Okay, so here's kind of when this starts to come into play, is when we don't give you the graph. So it's a little bit harder because you just can't count it. So you could either graph a problem like this out, or you can try using the distance formula. It doesn't matter which of these 2 points you say one is 1 and which one is 2, but it always sometimes is a little bit nicer to use the left point as 1 and the right point as 2. So since this is -3, I'm going to say this is 0.1 and this is 0.2, because I know if I were to graph it, this one's to the left because it's a negative value. So same thing here, this would be 0.1 for me. This would be 0.2, but it really doesn't matter which way you go. So for the first example, we're going to take the distance equals the square root of, okay, now x2. So I'm going to go to my second point, x is 4. And we're going to subtract x1, which is -3. So now you can see why I chose to do those points in that order, because now I'm going to have an and I can actually add this. If I would have went the other way, you're still going to get the same answer in the end, but then you're always going to have a negative number. So then we're going to add y2. So y2, this is 0.2, y is 3. So we're going to say 3 minus y1. This is 0.1, and the value is 4. And then we're going to square that whole quantity. So then we're going to say d equals the square root of, now this was an let's go ahead and fix that. So we have 7 squared plus 3 minus 4. And if I have 3 and 4, that means it's going to be a -1, or I owe 1, and we're going to square that whole thing. So d equals the square root of 49 plus 1. So d equals the square root of 50. And I would expect you to show all of this work. I don't want you to skip any steps or just do it all in your calculator. You can use your calculator, but I want to see all of the steps and all the work. So in the end, we'll take the square root of 50 to find that the distance is about 7.1 units. So we'll say about 7.1 units for this problem. Okay, and then the next point we would do here for an example is points 1 and 2 right here. So again, we can use the distance formula for that. So we're going to take the square root of x2 minus x1 squared plus y2 minus y1 and squaring that. And all that equals our distance. So we'll go ahead and substitute here. We're going to have x2 is 4 minus -4 squared plus y2 is 0 minus 1 squared. So d equals, again, this is an so we're going to have 8 squared plus -1 squared, and then so d equals the square root of 64 plus 1, or the square root of 65. So now we'll go to our calculator and figure out what is the square root of 65, and that's about 8.1 units. So right here for our answer, we'll be able to say d equals about 8.1 units for our distance for that second point. So again, if you have any other questions, you could look up some online tutors for these questions. However, in our book or the online tutors, it does not show you how to use the distance formula. So that was just another thing I wanted to introduce to you, so that way we could get in a habit of plugging numbers into a formula and then using that formula. But keep in mind that this is basically just using the Pythagorean theorem to help solve this. again, because looking back at our very first example, we were talking about those different things.